Slab is created using the Slab tool. In the Slab properties, click on Type drop-down menu, expose all the slab types. Slab type 1 to 12 relates specifically to table 3.14 in the BS 8110. This table is used for design of slab reinforcement based on the coefficient method or yield line method. Type 1 to 12 does not affect the slab load calculation on the supporting beams. So, don't bother about this during modeling and leave it as default type 1 for all slabs. There is a function to automatically set the correct type for each slab if you wish to use this moment coefficient method to design the slab. One-way slab is a special type of slab. The slab load will be transferred to the two supporting beams only in the direction of the span, in contrast to all beams for type 1 slab. One example is precast slabs. The direction of one-way span must be specified in the design angle input box. We will now explore slab creation. Go to Building Setout tab.
Library.
Click Slab Additional Loads. The Slab Additional Loads library is used to create or edit the additional dead loads, which are selectable from the drop-down menu in the Slab Properties dialog. As you can see, they are currently 3 preset Slab Additional Loads type. Select Room and the right table shows the load or material layers. The material layers can be changed by clicking on the drop-down menu. To review, edit, or add material, click on Edit Material. In the Material dialog, you can edit unit weight by clicking on the input. You can also add or delete a material. Click Cancel. You can change the layer thickness. The load value is calculated by multiplying the unit weight and thickness. The total load is shown at the bottom. Click Edit Load References. This can use to edit the load references of the slab additional dead load of the selected stories. The slab additional dead load with the same group as the selected source load group can be replaced by the load as specified in the target load group. If Apply Selected Load to All Slabs is checked, the target load will be applied to all slabs in the selected stories. Click Cancel to exit this dialog without any changes. To add a load type, click on Add New Load at the bottom. New load will be added. Rename it, say, Roof. Select a desired color. Click Add New Layer at the bottom. Select Material Cement Grout. Under Thickness, enter 30 mm and press Enter. The total load is auto-calculated. Click OK to save changes and exit.
Before inserting slabs, let us set up the load cases in combination. Go to the Loading tab. Click Load Cases and Combinations.
The Load Combination dialog will appear. You can add new load cases manually and then load combinations. However, it is easiest just to use the loading generator to automatically set up load cases and combinations. Pick Loading Generator. The Automatic Loading Editor dialog will appear.
At the top, use cracked sections in all load cases. If this option is checked, section stiffness factors that are set in the Material Section Effective Stiffness Factors dialog will be applied for all load cases. Leave this unticked, meaning uncracked, unadjusted default stiffness will be used. Generate combinations for steel member design. Since there are only concrete members, leave this option unticked. Add notional load combinations for geometric imperfections. This option enable automatic include of notional loads to all generated load combinations, using user input dead and life load factors.
Under Vertical Load Combinations tab, you can choose options for dead and life loads, including pattern or load arrangements. Different permutations of load arrangements are available. Equal sign means the span is loaded, underscore means the span is unloaded. For rigorous analysis, check all the options, including direction-dependent pattern loading. Go to the Horizontal Load Combinations. For simplicity, we are only going to generate the notional horizontal loading. Similarly, if used cracked sections is ticked, then section stiffness factors will be applied, which are set up in the Material and Section Effective Stiffness Factors dialog. Click OK. All the load cases and combinations will automatically be generated.
The left side shows different groups for reinforced concrete and steel ultimate limit state, ULS, and serviceability limit state, SLS, combinations. The right side shows the generated load combinations for the selected group. The load combination name can be changed by typing over it. The load factors are automatically generated based on chosen loading code. You can change the factors by double-clicking on a combination row. In the Load Factors dialog, just input the new factor. Apply Life Load Reduction allows you to consider life load reduction for this combination. Apply only to vertical load-bearing members, VOM for short. This means this gravity load combination will be used to design members with VOM option checked in member properties, that is, lateral load can be excluded from member design. These two options can also be changed in the main combination dialog under respective columns. Click Cancel.
At the bottom, you can add or delete a load combination. Click Load Case. The Load Case dialog will appear. This allows you to examine or change the load case parameters in more detail. There are a total of 16 load cases generated. You add or delete or edit the load case. Select load case number 3. Click Edit or double-click on it to access the load case editor. This description shows that this is a vertical load case and it is pattern life load case with load pattern 10 and pattern direction 1. Change can be made by clicking the drop-down menu. Click Cancel. Click Cancel again. Click OK to save and exit the load combination editor. Go to the Modeling tab and click on the slab icon. In the slab properties, enter the slab thickness, h equals 200 mm. Relative level. By default, 0 means the top of the slab is at the top of the floor level. A positive value will raise the slab. A negative value will lower the slab. Apply Z to analytical model will ensure that the slab level is also changed analytically when slabs are meshed in building analysis. Concrete cover. Enter a value of 30 mm. Design angle specifies the direction of placement of slab rebars. Since rebars will be placed exactly horizontally, leave this as 0 angle. Label position. These icons switches on the slab label and controls the position of the slab label on plan view. Insertion. By default, the slab insertion is beam region, which means the boundary of the slabs are enclosed by beams. The other options can be used if there are no beams. Go to the Loads tab. Under Service Dead Load, you can click on the drop-down menu and choose the load that was set up in the Slab Additional Loads library. Alternatively, use the default Enter Value option. Enter Service Dead Load equals 1.2 kN per meter square. Imposed load. If you right-click, you can select preset values, which are obtained from the selected loading code. Alternatively, enter the value directly. Enter or select the value 1.5 kN per meter square. Roof load, snow load and rain load field will only be enabled if these load cases are created in the load combination dialog. Slab does not contribute to floor diaphragm. By default, this option is unchecked. This means this slab, together with all other connected slabs, with this same option, will be converted to floor diaphragm in the analysis. All members that are constrained within the floor diaphragm will move and deflect as a single entity. Hence, the beams connected to this slab cannot lengthen, shorten, nor bend within the floor diaphragm. As the result, the beams will not have axial tension or compression, no minor bending, and no minor shear. Place the cursor over at the lower left region bounded by beams. A preview of the slab will be shown. Left-click. The first slab will be inserted. The yield line shows the tributary area load, which is automatically calculated onto the supporting beams. This is default method of slab load calculation onto beams. Create 2 more slabs between axis A and B. Now, change the imposed load to 2 kN per meter square. Create 4 slabs between axis B and C. Now, change the imposed load to 2.5 kN per meter square. Create 3 slabs between axis C and D. Close the slab properties. Check the structure tree. There should be a total of 10 slabs. We will now insert some cantilever slabs. Zoom to the top right part of the model. Cantilever slabs can be inserted by setting type 12 in the slab property. Click on slab icon. Under type, choose type 12. Go to Cantilever tab. Enter length of cantilever equals 1000 mm. Pick first intersection of axis to define start of cantilever. Pick second point to define end of cantilever. Move cursor to the side, where it is to be inserted. A great preview will be shown. Pick third point to confirm and insert the cantilever. The cantilever slab is created. Now, repeat the same steps to insert cantilever slab between axes 3 and 4. Notice the edges will join automatically with the adjacent cantilever. To insert a cantilever slab that does not span the entire length of the beam, we must enter values for D and B slab in the cantilever slab properties, as shown in this picture. Enter D equals 1000 mm. Enter B slab equals 2000 mm. Pick first intersection of axis to define start of cantilever at grid 2. Pick second point to define end of cantilever at grid 3. Move cursor to the side, where it is to be inserted. Pick the third point to confirm and insert the cantilever. Close the slab properties. We have used type 12 slab to model a regular rectangular cantilever slab. For irregular shaped slabs, you can make use of the Polyline slab edge function. Zoom to the top left of the model along the diagonal beam. Go to the Modeling tab. Click Polyline icon. For this function, you need to left-click continuously to draw the shape of the edge of the slab. First, click exactly on the insertion point of the diagonal beam, which is also the insertion point of the column. Then click on the second point. To change from line to arc, press A on the keyboard. Move the mouse cursor. Then continue to click on the next point. To change to line, press L key. To cancel the last point, press Escape key. You can also press F2 to manually input the next point. Now, try to draw a similar shape as shown. For the last point, click exactly on the end insertion point of the beam. Move your cursor away and check the point is selected correctly. Right-click and pick Finish to end the insertion. The slab edge line will be drawn. Click on the slab icon. Ensure type equals 1 is selected.
Type 200 mm thickness.
Click anywhere within the slab edge line and a new slab will be created, following the Polyline slab edge. Close the slab properties. We will now create a slab opening. Go to the View tab. Click on Tile vertically. Zoom into the lower left slab for both the 2D as well as the 3D view. Go to the Modeling tab. Click the slab opening drop icon. The slab opening properties dialog box will appear. By default, it will be a rectangular opening. Define the slab opening horizontal length. B1 equals 1000 mm and vertical length. B2 equals 500 mm. Pick the reference point of the slab opening. Usually, the intersection of axis at the lower left corner of slab is recommended. Pick the intersection of axes A and 1 as reference point of insertion. Move the mouse cursor. You can then pick any point to insert the slab opening. Alternatively, press F2 to manually define the relative coordinates. Enter 1000 mm, 1000 mm for delta x and delta y, respectively. Press Enter, and the slab opening will be created. You can rotate the opening by entering an angle. The angle is measured horizontal anti-clockwise. Drop definition. Instead of an opening, this allows you to change it to a localized drop. Check this option. Under Drop, enter -50 mm, which means this part of the slab is lowered by 50 mm. Fill load allows you to enter additional dead load for this drop region. Left-click on another location to insert this slab drop. Check and review the 3D view. Under Type, there are other options. Let's try Circular. Uncheck Drop definition. Click anywhere to insert it. Under Type, choose Polyline. For Polyline, you create an opening of any shape by left-clicking continuously. Click on the first point to start, second point and continue. To change from line to arc, press A on the keyboard. Move the mouse cursor. Click the next point. To change to line, press L key. To cancel the last point, press Escape key. You can also press F2 to manually input the next point. Now, try to draw any shape that you like. To complete, simply click on the first point to form a close shape. The Polyline opening will be created. Close the slab properties. Delete all the other openings, except for the rectangular opening, by selecting it and pressing the Delete key.